Rotations on a coordinate plane. So now we're moving along to a different type of transformation. So a transformation, you want to remember, is the changing of position of a figure in a coordinate plane. It doesn't change the shape or the size, it just changes the position. Transformations are made up of a pre-image, which is your beginning figure, and an image, your ending figure. So just a reminder, transformations, so far we have done translations, which is where the figure just slides around the graph, and we've done a reflection where the image flips over a line of reflection. Now, in most cases, for your transformations, remember, the size of the figure being transformed does not change. So the size does not change. There is one that will change, and we'll get to that later, but the ones that do not change the size are translations, reflections, and rotations. So right here you can see there's a pre-image of this figure, and now it became this new image. Notice there's the prime marks on the labels as well. That's another way to tell what image is the new one. So you can see that this figure here was A. So let's see, here was A originally. Now A is over here. So the A moved to the right of the picture, so this figure was rotated clockwise. Now I just mentioned clockwise. If we look at the next slide, what is a rotation? Well, remember, a rotation, it turns a figure through a specific angle about a fixed point, called the center of rotation. Rotations are also called turns. Okay, so you can see right here, clockwise, if you think of how the hands on a clock go, they turn to the right, that would be clockwise. Counterclockwise would be the opposite direction. Okay, so rotations can occur clockwise or counterclockwise. So that's one thing you need to make sure you pay close attention to, because a clockwise rotation is not going to be the same as a counterclockwise rotation. Now we're going to look at an example. Okay, so on this example, it says we're going to graph, well, it's already graphed, triangle PQR with vertices P at 1, 2, Q at 4, -1, and R at 3, 4. You're going to find the coordinates of its vertices when it is rotated 90 degrees, 180, 270 degrees, and 360 degrees counterclockwise. So you see right here, counterclockwise, so that means your figure is going to be turning to the left. And then you're going to graph each rotation in a different color. Well, it's going to be graphed for you, but you'll see. Now, as you go through each of these rotations, look carefully at the original coordinates and the new coordinates of the rotation. I'm going to look at those as I go through the notes. So on our first example, we're going to go counterclockwise 90 degrees. Now, turning counterclockwise 90, that means you're going to turn one time. So imagine the screen that you're looking at turning just one time to the left. Okay, so we're going to graph these. Here's our original points. You can see here are the original coordinates, and here are the coordinates of the counterclockwise 90-degree rotation. Okay, so let's look carefully at what we have here. First off, our R, notice it went to the right. Our Q went to the left. Sorry, I take that back. It went to the left one turn. And the P turned, and notice it went into the next quadrant. You can think of it moving into each different quadrant for each 90-degree turn that it makes. All right, so looking at the coordinates, we originally had 1 and 2. Now it became -2 and 1. What do you notice about the pre-image and the 90-degree rotated coordinates? Well, they're the same, So they both have a 1 and a 2, but if you notice, the x value moved to the y spot and the y coordinate moved to the x spot. Now let's look at the other ones. So for -1, did the same thing happen? Okay, well, the x moved to the y spot and stayed the same. The y coordinate was -1 and it moved into the x spot and it became the opposite. So what you might want to write over here is that the x and y coordinates switched spots and the y value became the opposite. Sorry for my bad cursive, but all right, so that would be something you can write in that spot. Continuing on. Now you may not get this right away, but keep going through the other examples. Maybe what I said the first time around didn't make sense, but then you get to the next one, you're like, oh, okay, I'm getting it. And continue on and you might get a little bit more. Okay, so on this one, we're going to go 180 degrees counterclockwise. That's 2 turns left. So that means, if you notice, here's our R, for example. It went 1 turn, 2 turns. It went into 2 different quadrants. So that's going to be a 180 degrees counterclockwise rotation. All right, so I'm going to just kind of ignore these right now. Let's take a look at the original coordinates and the new coordinates. Well, what I notice that they have the same digits. They both have 1s and 2s. Now the x was 1. The new image point is at -1. Then I look at the y, and the y was 2. Now it's a -2. Wonder if you're noticing anything. All right, so let me look at the next one. I'm going to actually skip down to the bottom so I'm not crushed in there. So R is at 3/4. So if I look at the x coordinate, the x originally was 3. Now the x became -3. The y was 4, and now the y coordinate became -4. Now thinking about what do we notice, we can say that the x and y coordinates stayed in the same spot, but became the opposite value. Okay, so that's something you can write there. All right, continuing on to the next one. Now we're going to go 270 degrees counterclockwise. So 3 turns to the left. So again, if I just look at the R, it went 1 turn, 2 turn, 3 turn. Oh, that right there should be an R and that should be a Q. That's no good. All right. So again, I'm going to ignore these other coordinates. I'm going to focus on just the original, the pre-image coordinates, and the 270 coordinates. So let's see. We have here 1 and 2, and 2 and -1. We have 4 and -1, and -1 and -4. 3 and 4, 4 and -3. Again, they have the same digits. For example, the 1 and the 2, and the 2 and the 1. So 4 and the 1, 1 and 4. But let's look closer at the actual values. So my original x was 1. Now I go to my new image, and the 1 is in the y spot, but became the opposite. The y coordinate was 2. Now it moved into the x spot. The x was 4 over here. Now the 4 went into the y position and became a -4, so it became the opposite. And the y value was -1. It moved into the x spot and stayed a -1. Same thing on the last one. The x coordinate was 3, and the 3 moved into the y spot, became the opposite, and the 4 for the y coordinate switched into the x position. So when I get to my fill in the bottom, what I can say is the x and y values switched places, and this time the x coordinate value changed to the opposite. Something like that. Okay? All right. And the last kind of rotation, a 360-degree counterclock rotation, 4 turns to the left. Hopefully you know a 360 is a complete circle. So we went, oh, gotta not do that. Went here, to here, to here, to here, and back to the beginning. So if you looked at the original coordinates, 1, 2, a 360 gives you the same coordinates. Same coordinates. So what can we say about the coordinates? The x and y coordinates stayed exactly the same. All right, so I know this is a lot, but we will be doing this for multiple days, so hopefully you catch on by the very last day for sure. So on this slide here, it has the rules. Now the rules are very important. So we have the counterclockwise rotation and the the clockwise rotations. So if I look at the first example, I have the counterclockwise 90 degrees. So here's my rule. It started at y or xy, the original, and notice they switched positions and the y coordinate became the opposite. You can see right here it's written in words also. Change the sign of the y coordinate, then trade spots. So like for example, if 3, 2 was my original, I'm going to change this y coordinate to the opposite and then switch spots. So I'm going to start with the y coordinate. It's a 2. So I'm going to change it to the opposite, put it as a -2, and switch its spot to the beginning. Leave the x as it is. Okay, so that's one way you can look at it. When I go to the next one, a counterclockwise of 180, the xy is just going to become opposite of x and opposite of y. So it tells you right here, change the sign of the x and y coordinate. So for that one, if I had the original coordinate of 3, 2, it just says opposite of x, opposite of y. There's my new rotated figure. Now if I do a counterclockwise 270, take my original xy, switch the positions and change the sign of the x coordinate. So if my original point was 3, 2, I'm going to change the sign of the x. So the x is going to change, and I'm going to switch positions. So starting with that one, the 3 is going to become the opposite. I'm going to change its position and put the y first. So I switch them around. And then, of course, the 360, xy just stays as xy. Okay, so now I'm going to look at the clockwise rotation. Remember, clockwise is turning to the right. So if I go 90 degrees to the right one turn, it says I'm going to take my xy, I'm going to switch their positions, and notice the x became the opposite. So I'll use my same original point, 3, 2. My x is going to change. So the 3 is going to become the opposite and switch spots. So I'll put that second and keep the y. So that would be my clockwise 90 degrees. Then I have my 180 clockwise, turn to the right. XY, they both become the opposite. So again, I'll use my 3 and 2 original points. I don't switch spots, I just make each coordinate the opposite. And that's my clockwise 180. Then I have my clockwise 270, 3 turns to the right. XY becomes negative YX, so the Y's are going to switch spots and become the opposite. So 3, 2 again. So the Y coordinate is going to become the opposite. So if it was 2, it's going to become negative 2. That's going to switch spots, and the X will stay the same. Now, if you noticed, comparing the rotations at the top and the rotations at the bottom, I color coded. These give me the same new image coordinates. So a counterclockwise 90 is the same thing as a clockwise 270. A 180 degrees, you can see right here, 180 degrees, the green ones, clockwise is the same as a 180 degrees clockwise. And then I also have counterclockwise 270 right here is the same coordinates as the clockwise 90. All right, so if I were you, I would write down a little cheat sheet for these counterclockwise and clockwise rotation rules, because these will be coming in very handy for the next couple of days. Good luck on this assignment. Again, write down these rules with their degree rotations so you can use those to help you with the assignment for today and, of course, the next couple of days. Good luck.